Good afternoon to those of you joining us for our webinar today, or good morning, depending on if you're in the West Coast. My name is Steve Matlin. I'm CEO at Matlin, and I'm going to be speaking today, starting our new webinar series about clinical applications of telomeres in diet, supplements, and its relation and role in diabetes. As you can see on the screen, we're going to have a couple of other webinars coming up over the next months, focusing on exercise, inflammation, and arthritis. And then we'll have one about stem cells and fertility. Finally, we'll do one more on aging. I'm going to take about 30 minutes or so to go through the presentation. I'll try to go at a fairly quick pace and be able to take some Q&A questions at the end. If you have questions, you can write them in the chat box for the Q&A to us. If I don't get to your questions at the end, we'll be happy to respond to you via email or have a phone call or whatever is required. And if you aren't able to stay for the entire presentation, we can also make that available to you. So let's go ahead and get started. So we're going to focus, as I said, around telomere analysis in the fields of diet and supplements and diabetes, and how telomere maintenance is enhanced and supported by good diet and also by supplements, and harmed by poor diet, and how all of those factors contribute to the development of type 2 diabetes, and how our TAT, Telomere Analysis Technology, assay, can be useful in clinical, earlier detection of clinical risk of developing type 2 diabetes. So just very briefly, just for anyone who may not be familiar with our company, LifeLink has now been around for quite a few years. We were founded in 2010, originally as a spinoff of the Spanish National Cancer Research Center. We were headquartered in Madrid. And I think we can say modestly but truthfully that we are the world leader in the field of telomere diagnostics. We offer our testing services to physicians and their patients, as well as to academics and researchers and corporations, pharmaceutical companies, biotech, nutraceutical and supplement manufacturers in more than 40 countries around the world. Our technologies are being used for people who are looking to adopt new and innovative biomarkers that can fundamentally contribute to longer health and lifespans. We have a number of unique proprietary high-content technologies. One we'll focus primarily is on TAT test, as I said before, which stands for Telomere Analysis Technology. It's the only technology in the world that's commercially validated for measuring telomeres at the individual chromosomal level, which I'll highlight why that's important a little later on. And in fact, we are the only laboratory in Spain, which is a U.S. federally accredited CLIA lab. We also hold licenses in all of the states in the United States that have an additional licensing requirement, with the exception of New York, which is a very difficult state. If you're a New York physician and want to work with us, contact us so we can discuss options about how we can make that work. And we're also accredited through the ISO 15189 certification in more than 65 countries around the world, including all of Europe and many major countries like India, China, Korea, Indonesia, among others. We currently provide service in about 40 markets and report our results to our physicians in about a dozen languages. So let's just have a quick review, very basic review of telomere biology. I'll go through this very quickly. Presumably most of you already know this. If you want more details around this or on any aspect of what we discussed today, we have many other presentations which go into more depth. Just let us know. So as we all know, telomeres are the protective caps found at the ends of chromosomes, and which play a very significant role in the aging process. And they don't encode for gene expression or protein or enzyme expression like our genes do, but rather they serve to protect that part of our chromosomal material in the process of cellular replication. And due to the what's known as the 3 to 5 end replication problem, every time a new DNA is synthesized, there is some loss of this telomere fragment. So telomeres essentially serve as a biological clock. And if you look and measure telomeres, you can basically see how much of the senescent or the replicative capacity, of the cell remains, and how close that cell is to senescence. And there's a great deal of heterogeneity in telomere attrition, both between individuals, in tissue types, and even in the nuclei of specific cells, even among the same tissue. And hence, being able to look at telomeres individually is really, really important, as we'll discuss. As a consequence of the role of telomeres driving senescence, they are a major contributing factor to virtually every age-related and chronic disease that we know about, and there are more than 25,000 publications that support this. So as we said, cells have a finite capacity to divide. This is referred to commonly as the Hayflick limit. The scientist Leonard Hayflick, who demonstrated roughly 50 years ago that cells can only divide so many times before reaching this limit, typically somewhere between 50 to 70 cellular duplications, depending on the type of tissue and the media. And then they reach this point where they enter into senescence and ultimately should go into apoptosis. And this is simply another way of looking at this. Essentially, the aging process is being driven in large part, not uniquely, but the largest single factor by telomere attrition. And so telomeres are getting shorter in these cells over time. They're losing replicative and proliferative capacity. Therefore, the tissues and tissue systems are aging, and that is driving us through the aging process. And as I said earlier, this is supported now by over 80 years of research. The first publication on telomeres was actually in 1938. So 2018 marks 80 years since that first document, that first publication. And there are now roughly 25,000 publications at a rate of 100 or so publications every month, contributing to the science and increasingly the medical and clinical application of telomere biology in many fields. And here are just a selection of some of the articles that have occurred over the past few years. But essentially, in any field of medicine in which you have an interest, if it is a chronic or an age-related disease, there is probably literature demonstrating what role telomeres play in those diseases. And if you have a specific interest and want to see more articles in a specific area, let us know, and we can point you to the best articles or even provide them to you. Now, why do we think this is important? This is just another way of perhaps looking at the same subject as we finish this little introduction of our telocentric view of the world, if you allow that expression. Short telomeres drive damage to the DNA into the cells, which in turn affects the tissues and organ systems, and of course then that, together often with injury or externality and other factors, whether it's inflammation, obesity, stress, abuse of tobacco or other genetic or epigenetic factors, can lead to disease states and creation of diseases. And we list here some of the many important diseases that are the most common ones, but there are many, many, many others. So we really think that telomeres sit as a fundamental root cause, not only of aging, but of age-related diseases. And that makes it very relevant if you're working in preventive and personalized medicine, where the goal is a proactive medicine, where we try to deal with patients who are hopefully relatively well and want to maintain that status or enhance that status and maintain their health for as long as possible. And just before we finish this, I'll just make one observation again around the role of the heterogeneous nature of telomeres. Here we can see in a study of more than 800 people, so quite a large sample size, that telomere length can be very different at birth, and the rate of telomere attrition over time can also vary widely. And this, it makes, or is the hallmark of what could be a good biomarker, because of course if all of the dots are on the line, if there was no scatter, if you will, on the graph, then there's really nothing that could be done. It doesn't really matter what you do, there's really no point of measuring something that can't be changed. But we know that the rate of telomere attrition, that is, although there is an overall slope of the line downward in a set of 800 people, that slope can look very different for each individual. Some people can have a very steep slope, and others can have something that approaches almost being parallel to the graph. And hence, those individuals are aging very slowly and have a much greater chance of not only having a much longer lifespan, but having a much greater health span, because they have much more proliferative capacity in their cells, and hence their risk of developing age-related diseases is remarkably diminished. And really, this is what we're saying. You know, what we really are all striving for, every one of us, whether you're a physician, whether you're a patient, whether we know it or not, we really would like to see this blue line be our personal lifespan and health span graph rather than the purple line. Because all of that difference between the graphs, between the blue graph and the purple graph, that's quality of life. That represents physical and mental autonomy, the ability to perform and do activities and things that we enjoy almost as well as when we're 60 as when we were 30. And there is an astounding amount of increasing evidence that is more than achievable if we take the steps to preserve our health and be proactive of our health from a relatively early age. We can maximize this quality of life. I think we can all agree that conceptually living to 100 is interesting, but it's far more interesting to think about living to 90 and being extremely healthy, or as healthy as possible, until the end of our days. Now, we said that there's a lot of heterogeneous factors in telomere length. One of them, of course, is genetics. You are born with a certain telomere length. Today, at least, we can't do anything about that. You have to accept whatever that is. So wherever your starting point is, from what you've inherited, your genetic material from your parents and so on, you can't change that. But environmental factors, where you live, whether you live in a, it's not the same to live on a farm in the countryside than to, say, live in a very highly contaminated city. Now, not many of us can necessarily change where we live, but it's something to take into consideration. The part where we can most impact, of course, is lifestyle, and this is where we're going to focus today. So in particular within lifestyle, of course, we can talk about exercise, we can talk about bad habits, we can talk about stress management. But what we want to focus today, a little bit in the presentation today, is talking about the role, good and bad, of certain dietary habits, supplements, and how this impacts on our telomeres and on the development of type 2 diabetes. So we're going to focus, as I said, on diet, supplement, and then diabetes. In terms of diet, there's been a lot of research done in this field, and of course, any healthy diet is obviously going to be better than a poor diet. But the diet that we want to focus on a little bit, one that's been heavily studied, is what's called the Mediterranean diet, which many of you know and will be familiar with. And the Mediterranean diet has been the subject of the Nurses' Health Study carried on by Harvard Medical School for going on 15 or more years. That I think is something like 10 or 15,000 nurses enrolled in the study. And the study has published that the greater adherence to a Mediterranean diet was significantly associated with longer leukocyte or white blood telomere length, a marker of biological aging. And of course, that also then correlated to much better health outcomes. Those individuals had better body weight, lower body fat, less disease, greater health. On every biomarker, it was significantly improved. So what is a Mediterranean diet? So Mediterranean diet has various components. It's a diet that has a lot of fresh foods. So vegetables, the raw, the better, in the sense that the more you cook and fry and do things to the vegetables, the more nutrients you lose. Fruit, lots of it, and hopefully less processed. And it's better to eat an orange than to drink orange juice. And it does include things like wine, which have been shown that in moderation are also things that are good for us. You don't have to have wine if you don't like it, but wine and perhaps even modest quantities of beer are also probably helpful. But it's more than that. It's also having a lot of leafy green vegetables that are rich in antioxidants and metals, potassiums and zinc and things like this. And that includes spinaches and kale and cabbage and asparagus and broccoli, and then matching it with appropriate proteins. Of course, you can have chicken and pork and beef in reasonable quantities, but omega-3s are derived from bluefish like salmon and other seafoods, and these are very good for us because of the cardiovascular protection they afford, and because all of these factors have been shown to also diminish inflammation, reduce cellular turnover, and hence contribute to telomere maintenance. And then you can complement it with things like dried fruits, ideally not to have fried and salted nuts, but rather raw almonds or walnuts, and these are things that are very healthy for you in reasonable quantities. And then, of course, using olive oil, both for cooking and for eating, has been shown to be much better than corn and soy oils that are perhaps sometimes less expensive, but as we'll see shortly, not so healthy for us. Now, some of the things that we know on the flip side that are not part of the Mediterranean diet are highly processed breads coming from wheats, white breads. Not only are they full of sugars and chemical preservatives, but this whole class of foods contributes to what's called advanced glycation end products, or aging, or ages. And this is causing damage to you by speeding up this glycation process. And it increases, of course, your blood sugar levels, and that, as we'll see a little bit on, is another contributing factor towards the development of type 2 diabetes. So trying to minimize the intake of highly processed wheats is something that should be our goal. And of course, as I mentioned earlier, we've got a real problem around the world with high fructose corn syrup, which is manufactured so cheaply that it is now put virtually in every food, every packaged food that we take. And it's very difficult to get away from these products. But fructose is a very detrimental product and contributes to a lot of glycation. And of course, you get this in any kind of sugary cereal and any kind of soft drink. You get it even in ketchups, any kind of sauce. It's really, really hard to avoid, but you've got to make an effort to try to avoid these processed foods. And of course, having some of this occasionally is not the issue. We don't demonize junk food. The focus is trying to realize that it has to play a certain portion of your diet. It cannot be the majority of your diet. So if you can reduce the role of these products, this will also reduce the level of inflammation and the rate of aging. And of course, then there's sugar itself, which I think, along with tobacco, is probably the next candidate for the kind of treatment that tobacco, has had over the last 20 or so years, where it's really become pretty apparent that there have been a lot of paid studies that have repressed the data that show the detrimental impacts of overconsumption of sugar, which in my view, in our view at least, probably outweighs that of salt consumption or other saturated fats like butter. Sugar really is a very detrimental food, and the enormous increase in sugar intake contributes, of course, to a huge amount of obesity, which again is driving inflammation, which is again contributing towards diabetes as well as cardiovascular disease. So trying to reduce the amount of sugar, the addiction that sugar creates, and the facility with which we have sugar at our beck and call constantly is something that we need to really try to break that cycle. And we have to make an effort to try to get away from the candy and all the other things that seem to be always at our fingertips, but actually really has a big impact on blood sugar levels and on the aging process. And as I alluded to earlier, when cooking, even if we don't cook a lot, our food, when we go out, it is being cooked in some kind of oil typically. And unfortunately, the oils that are typically used are not olive oils, because olive oils are more expensive. They're more commercial oils, such as soybean, canola, and corn oil. And these oils are highly refined and use toxic and potentially dangerous cancer-causing chemical solvents such as hexane. And they have a very high heat point, so they can be used to fry a lot of food. But the detriment to that, of course, is they present a lot of oxidated polyunsaturated fats. And all of that is creating a lot of inflammatory damage inside the body. So to the extent that we can, at least at home, try to avoid those oils. And when you're eating out, be conscientious of the food that you're being served is almost very likely to have been prepared using these types of oils. Now, let's move on and talk a little bit about the role of supplements and telomeres. Let me start by saying that supplements come after diet. If you don't have a reasonable diet, then of course you can't pretend that any supplement, or even for that matter any pharmaceutical medicine, can offset a poor diet. So we can't just tell our patients, just take some omega-3s because you don't ever eat any healthy fish or you don't eat vegetables. The role of supplements is to support what is already, hopefully, a diet that is intended to keep you healthy, when, in particular, there are certain substances that are difficult to get sufficient quantities from the foods by themselves. And there are many, many, many studies in this area. And I'll just name some of the main vitamins, and I won't go through it in too much depth because many of you will know this already. And of course, we want to make the papers available to you if you want to do further reading. But we know, for example, that vitamin B12 is very effective at reducing oxidative stress. This is important for telomere maintenance. We know that vitamin D has strong anti-inflammatory and anti-proliferative properties. And of course, it's very important in calcium binding, and few people get enough vitamin D because we don't get enough time in the sun, because we spend, even here where we live in sunny Madrid, Spain, most of people spend most of their day in the office, and you don't get vitamin D production from artificial light. So it's very difficult to get enough vitamin D, and these are inexpensive supplements that most people should be taking, especially under medical supervision and when monitored and properly tested by competent labs. Now, other vitamins that we want to be looking at, again, that have shown metabolic pathways to support telomeres include vitamin C and E, and metals such as magnesium, zinc, folate. And of course, we are going to be getting a lot of these things from the foods that we discussed before, but probably not in sufficient quantities. So a good multivitamin, good set of supplements that provides these is really going to help us. We're not recommending overdosing on vitamins. They can have detrimental effects if you take too much of it. So it does need to be done properly, and we really encourage this to be done as part of an overall program. But there's an overwhelming amount of evidence around supplements having more benefit than harm, certainly these supplements that have been studied now for many, many, many years. And then, of course, things like omega-3, which I think all of us know the roles of omega-3 in cardiovascular health, and things like curcumin have been shown to also help mediate inflammatory response. And this is just some of the main supplements that we could talk about, and of course there are more. Next thing I'd like to mention is there's kind of another class of more specific supplements that are designed to directly act upon telomeres themselves. They're often called telomerase activators. And most of these are based on a plant, which the Latin name of which is astragalus, which is a plant typically found in the Far East, in China, Nepal, and these regions, in which for many hundreds or probably even thousands of years has been used to make tea. Basically take the roots of the plants and boil them and make tea, just like ginseng and other traditional medicinal properties. And a lot of research has been done on this extract, and there are many, many companies now that manufacture and offer a telomerase support or telomerase activating supplements. We have done a very thorough presentation, which we're not going to go into now because there are, as I say, a lot of companies. But if you are interested in looking in this, if you're interested in offering to your patients the possibility to use these telomerase activating substances, let us know. We're more than happy to send you this presentation. We don't have any commercial or financial interest in this. We do this as a tool to facilitate this to you as doctors. I would say that, again, this is the next level down. You've got, if you're not having a good diet, if you don't do some exercise, if you don't manage stress, you don't take basic supplements, jumping to this won't do anything for you. If you're doing those things and you have patients who have the discipline to undertake in a sustained way the programs that you'll be recommending to them, and they say, well, what more can I do? And they have the financial wherewithal where this kind of investment in their health is something that they can permit, then by all means, I think there are some companies out there that have some very good supplements, and you can research them, and you'll clearly see which ones are the ones that you want to be working with. So let's now turn in the last kind of section of the presentation to the role of how telomeres contribute to type 2 diabetes, partly as an outcome of all the things we've talked about in terms of diet and nutrition. Just a couple of astonishing figures before we get into the biology of diabetes, which is just the level of diabetes that is now occurring globally, contributing to over 5 million deaths a year, probably more than that. With an estimated over 400 million people currently with type 2 diabetes, and probably another very significant number of undiagnosed, particularly in countries where they don't routinely test for these things. We think about that type 2 diabetes is typically adult onset diabetes, and obviously we're excluding type 1 in juvenile diabetes as well as gestational diabetes. This is something like 5%, perhaps as much as 10% of the world above 40. If we have 8 billion people on this planet and 4 billion are above 40, I don't know the exact figure. It's a very, very, very scary number. And the cost around diabetes to treat it, and the societal cost, and the individual cost, I'm sure many of you know, is tremendous, and it has a tremendous impact on lifespan and, of course, on health span. And over 90% of all cases are type 2 diabetes. And this is just where it's going. It's only going to get worse from here. The World Health Organization is estimating that number is going to grow by more than 50% to over 600 million people in the coming 15 or 20 years. So we've got a real epidemic on our hands, and the magnitude, perhaps not as well known as cancer, cardiovascular disease. People somehow maybe play down the role of diabetes, but it's a very significant problem. Now, we've already said we're going to focus on type 2 diabetes. We're not going to talk about type 1, which has got more genetic causes and gestational diabetes. Let's focus really on type 2. So in type 2 diabetes, there's over 300 plus publications in the literature that have shown that short telomeres, which are driving, again, cellular senescence, and hence reducing pancreatic function, contribute to the onset of type 2 diabetes. And that makes a lot of sense because, as you can see here in this little graph, the pathway through which insulin resistance develops feeds back to the beta cells, and then we have this problem of glucose tolerance and glucose maintenance. And so the cycle that of glycation and glycemia that we get into is being driven to a larger degree by diet. And one of the example that I like to use is simply an analogy of driving a car. If we imagine, and I'm taking a bit of an extreme example, but if we imagine an analogy of eating a meal which is what too many people do nowadays, unfortunately, which is to sit down, having probably not had a proper breakfast, and having fasted for a number of hours, and then to have in 15 or 20 minutes 2,000 or 2,500 or even 3,000 calories of processed, high content, caloric, sugary, fatty, salty foods, like a fast food meal, for example, where you're resting, your basal glucose is very low, and suddenly it spikes enormously. The analogy is like taking a car, which has the engine's been cold, it's a cold day, you get into your car, you turn on the engine, you start driving it to red line at 7,000 RPM for 10 minutes. You don't give the car an opportunity to warm up, you don't give the opportunity of the oil to flow into the engine block. Then you stop the car suddenly, park it, walk away, and come back 6 hours later and do the same thing. Well, that obviously is extremely detrimental to the car, and that's extremely detrimental to your pancreas. So that's essentially what we do when we don't have a diet that slowly provides nutrients, that's absorbed slowly, like the kinds of foods that you would eat in the Mediterranean diet. They don't have these huge spikes in glucose and blood sugar level. And ultimately, what it does is it wears out the pancreas in its simplest terms. Hence, the shortest telomeres are causing these cells to become senescent. There's a huge inflammatory response of the pancreas and a loss of ability to regulate insulin levels, and therefore diabetes type 2 starts emerging. And this is just another kind of look at how the elevated levels of cellular glucose is promoting and driving oxidative stress, and then this is causing damage or injury to the cells and decreased insulin sensitivity, which then is impacting on the telomeres, and of course, less insulin sensitivity requires greater insulin secretion, which is putting greater demand on the pancreas, and we get ourselves into a vicious cycle here. So where can the TAT really help you in this context? I'm sure most of the stuff I've discussed in diabetes is well known to you. Well, we know many of the prevention tips, right? Increasing physical activity, eating healthy, we've discussed that, maintaining a healthy body weight, reducing inflammation, avoiding tobacco, managing alcohol, which of course has a lot of sugar as well. But what we want to also include in here is we think that our TAT test, our Telomere Analysis Technology test, can be an early warning signal flag for you as a physician and with your patients in the context of your overall program, even for individuals who don't show abnormal levels of A1C or fasting glucose. Because very often what we've seen is that those tests often don't reveal the onset of type 2 diabetes until it's almost on top of us. And then reversal is much more difficult. So the point we're making is that people with shorter than normal telomeres who have accelerated biological aging are indeed at greater risk of developing type 2 diabetes, even if the more traditional biomarkers may not yet show it. And that is an opportunity there for you to take a proactive, constructive intervention, which is not yet pharmaceutical, but rather reinforces the need for these individuals to make meaningful changes in their lifestyle, and then, of course, monitor the efficacy of their program, not only for their overall health program, but also to see if they're moving towards developing this very serious disease. So there's a lot of literature on this. This is just a small selection of the many, many good publications that have been put out in major journals. And if you'd like to read more about it, let us know. We can provide supplementing the documents or the publications that support all of the things that we're saying this afternoon. And finally, I'll just then close a little bit with, therefore, how we can use the test. Hopefully, many of you are already working with us, and others who maybe are thinking about it, and how we'd like to describe how this can be done. The importance of looking at risk stratification biomarkers, which is what telomere measurement is, like measuring blood pressure, or looking at fasting glucose, or looking at any biomarker that you look at periodically, cholesterol, is you would never do those tests a single time. You would never say to a patient, your cholesterol is great, your blood pressure is great, you're fine, we're not doing that test again. These are not genetic tests where you look for an alteration or a mutation to assess the risk of a disease, and then you leave it. Your genes aren't going to change. Again, not yet. Maybe someday soon they will, but for the moment, they don't. But glucose changes, cholesterol changes, and it can evolve positively or negatively. You've got to monitor. So really the importance of doing this is not just to test once, which allows you to establish where you stand biologically, say, your biological age versus a large database, which is how we validated our assays, but rather to then monitor yourself over time and look at the efficacy of your program and how are you evolving. So really what we'd like to see people do is to do this. You have a test at the beginning, they begin working with you as a patient. Maybe they've already been working with you as a patient, but they've never tested. Well, now is the opportunity to see where they are. And then perhaps once a year or once every 2 years, we don't recommend testing every few months because this is not a metabolic test where you see differences quickly. You retest. And that's going to give you the insight into what is the rate of aging of this individual and how quickly are they going down that slope. Is it very steep, like in the graph we saw at the beginning? Is it steeper than that general line? Is it shallower? And how effective is their lifestyle program? And hopefully this is a tool, a very positive tool, to constructively incentivize people to stick with a program, along with the other biological and innovative tests that you do for your patients. This plays a very constructive role. And indeed, we see an individual who does have abnormally short telomeres and maybe has their family history or other indices or factors of risk for, say, diabetes. And again, that's an invaluable opportunity for you as the physician to sit that person down and say, look, you are likely to be on the path towards developing diabetes at some point in the future. And we want to avoid that together. And we need to take this seriously now. And maybe a decade away. But that's the opportunity because in 10 years' time, it won't be so easy. And just to briefly, if you're not already familiar with our reports and our customer service and all of the educational materials we have, really they're the best in class. There's no other company that provides reports at the level of detail, both in terms of the measurements, the interpretation, being able to look at the shortest telomeres, which, as I said earlier, the shortest telomeres are the ones that drive cellular senescence. So any test that only provides average telomere length really doesn't give you any clinical utility as a physician or as a patient. Our test is set up to be longitudinal so people can track over time. That's also very important. And people have the opportunity to do an anonymous health questionnaire online, again, in about a dozen languages. That will dynamically integrate into the report for the patient, and that's very useful for you as the physician to interpret the results and understand what factors may be contributing to a patient's results. So this is all very innovative stuff that no one else in the field has ever done. And then just briefly, just to highlight the technologies, the telomere measurement goes back a few years. The original technologies go back 30 years, actually, to 1988. But it's really with the advent and the clinical validation of our own technology, TAT, Lifelink Telomere Analysis Technology, with its clinical validation as a clinical test by the U.S. federal government, by the European ISO standards, that you now have a tool that you can use clinically. Because these other tests, essentially what they do is they can give you perhaps average telomere length, but they don't give you this critically short telomeres, and they don't really have the levels of reproducibility and clinical validation that you need to have in personalized medicine. And the other factor, of course, is scalability, because one of the things that we've done is we've made this test very affordable. So this is a test that for the kind of patients that you presumably are working with in your medical practice, who do understand that a small investment in your health is important, this is very affordable. It's really, really affordable, and it should be something that every patient, hopefully, that is in a program, in a concierge program or in a preventive or personalized medicine program, should be doing once a year or once every other year. And this is just kind of highlighting the technology, the fact that we are the only technology, you see in the upper right corner, TAT, that's actually measuring individual telomeres by nuclei. And since we get the smallest unit, we can get all the other data. So basically, we can provide all the information that these other techniques can provide more accurately, but more granularity. And that is really a crucial difference in clinical utility. Test is a blood test, if that wasn't already clear. We provide logistic support, great customer service. We deliver kits to our physicians directly in all of Europe with prepaid overnight air bills to bring the samples back to our laboratories. And to the rest of the world, in the markets in which we're present, we work with laboratory partners. It's one tube. Patients don't have to fast. Our results are delivered typically back, depending on the country in which you are working, in 1 to 3 weeks. We provide reports, as I said earlier, in about a dozen languages, all of the major European languages, but also languages including Turkish, Russian, Japanese, among others. So if you ever have a situation where you have a patient and you need a report in one language for yourself and a different language for your patient, we can provide that. So it's really very easy. And as you can see in the picture here, we're looking at more than 100,000 individual telomere measurements per patient sample. That's really important because of the heterogeneous nature of telomeres. Just a few measurements would not give us any value. And the amount of computer processing and the confocal microscopy that we've developed in order to do this is unmatched. There is simply no lab out there that has a technology as robust and sophisticated as what we're doing. So I'm going to pause here to allow a couple minutes for people to ask any questions. Hopefully you found this helpful and useful, and thank you very much for your attention, and we'll take a break of 1 or 2 minutes, and then we'll answer a few questions.